Okay, so this is a video on roots of polynomials, which is chapter 4 of Core Pure 1. It's a chapter which the place that it goes later in mathematics is really cool, but actually at the moment it's kind of quite a lot of algebra busy work. You've got to be really careful with your algebra, solving equations and things like that. Don't dismiss it. There are some really interesting things that it leads to at university, but it can be quite a lot of algebra. Anyway, I'm going to start off because there's going to be some Greek letters in here, and I just wanted to quickly kind of talk about them. We're actually going to be mainly focusing on kind of using the first four. It'll be useful for you to be able to draw them. Alpha, beta, gamma, and delta. They obviously do look a bit like A, B, well that looks a bit like D, and then gamma looks like an alpha but the other way around. They both look a bit like fish. Beta is a B with a capital B with a long tail. Okay, so roots of polynomials. We're going to start looking at a quadratic. Now this really isn't anything new, but by making certain observations we're actually able to speed up some processes. In fact, a lot of things in this chapter you could do in a very long way round, but we're going to find some kind of shortcuts by thinking about things in the polynomial. So if I was to factorize this quadratic, I could end up with something that looks like this. Where alpha and beta are the roots. You could bring the a out of the front. That would mean that there's no coefficients in front of the x's. And we can see that this would be the kind of the polynomial for whatever alpha and beta are, because we don't know what alpha and beta are because we don't know what a, b and c are. But alpha and beta are the roots. Okay, well if I was to start expanding this quadratic and doing it very carefully, I'm going to leave a on the outside. I would get something like this. X squared minus alpha x minus beta x plus alpha beta. And then if we carry on a little bit longer, I could collect up those like terms. It would look something like that. And now expand it out further. We get this. And this. And this. Well, now we're going to compare coefficients, because one of the things we know about polynomials is that if two polynomials are equal, the coefficients of each term must also be equal. So a must be equal to a, because that's the coefficient of x squared. Well, yeah. B must be equal to this. And c must be equal to this. So overall, we get that a is equal to a. We get b is equal to minus a alpha plus beta. And we get that c is equal to a times alpha beta. Well, that's not very interesting, but this one does tell us that minus b over a must be equal to alpha plus beta. Now, if we were to assume that a was 1, this is actually not that surprising a result. And the same here, if we have c over a is equal to alpha beta, neither of these are very surprising results. If I was to assume a was 1 and give you this quadratic, well then how would you factorize this quadratic? Well, you would just tell me that we need two numbers that add together to make 5 and multiply together to make 6, and they are 2 and 3. 2 plus 3 is equal to 5, and 2 multiplied by 3 is equal to 6. But we know that actually the roots of this polynomial, if it was equal to 0, would be x is equal to minus 2 or x is equal to minus 3. So in the context of what we've actually done up here, what would be probably a better idea is to think about 5 as being, well, we would say minus 5 is equal to minus 2 plus minus 3. And 6 was equal to minus 2 multiplied by minus 3. And this matches exactly the two equations that we just got. Again, with a equals 1. And that is the roots of a quadratic. We can see overall, so just to summarize the roots of a quadratic, if you have ax squared plus bx plus c is equal to 0, then adding the two roots together gives you minus b over a, and multiplying the two roots is equal to c over a. And at this point, I'd like to just also think about that if these were complex, if alpha and beta were complex, if you add together the two complex numbers, well, if they are conjugates, because the a, b, and c are real, then you would expect to get a real number. And if you multiply the conjugates, you should also get a real number. So this kind of really nicely relates to the complex numbers there. So now we're going to move on to a cubic. And I'm going to say that I've got a cubic equation here. I'm keeping the quadratic on the right hand, quadratic information on the right hand side here. The roots of my cubic are going to be alpha, beta, and gamma. Again, I don't know what a, b, c, or d are, and I don't know what alpha, beta, and gamma are. I'm doing this completely generally. And I'm going to do, and this is going to be slightly tedious, we're going to multiply this out. So what can I say? I can say that if I factorize out a, this could be factorized like this, where the three roots, alpha, beta, and gamma. So I'm going to multiply the first two brackets, and plus alpha, beta, and that's multiplied by x minus gamma. You can collect the first few terms, the second two terms there. And then multiply it out again. I'm going to keep using my trick of writing terms on top of each other, like hundreds, units, tens, etc. So multiplying all three by x. Not close brackets yet. Multiply all through by minus delta. So minus gamma times x squared. So I get minus gamma x squared plus multiplying this second term, I'm going to get gamma open brackets alpha plus beta x, and finally minus alpha beta gamma. And simplifying that, I get x cubed. In this here step, I can see that I get one of each. For x squared. Now on this one, I can see I get alpha beta plus alpha gamma plus gamma beta x, and finally alpha beta gamma. Now when we compare coefficients of this to the original cubic, which is I'm going to factorize out a for the original cubic, which would be x cubed. I'll just show the original cubic at the top, plus b over a x squared plus c over a x plus d over a, if I'd factorized out the a, as is the case. Overall, you can see that we get these equations. We get that alpha plus beta plus gamma is equal to minus b over a. We can see that alpha beta plus alpha gamma, that should be an alpha there, plus gamma beta is equal to just c over a. And finally, alpha beta gamma is equal to minus d over a. I've just moved the negative signs across here just to make it like that. Now at this point I'm going to bring down what the result was for a quadratic, and you'll start to see that there's a really common pattern here. They both start off with minus b over a when we've added the roots together. These are multiplied in pairs and we get c over a. And these are just all the roots multiplied together and we get minus d over a. Now, that one is 3 roots multiplied together. We didn't have that for quadratic, so it's kind of gone off the bottom. But minus b over a, c over a, minus b over a, c over a. And this actually allows us to, without doing all this expanding, have a guess as to what the quartic might be. So just to recap before we go on, the cubic, add all the roots, it's minus b over a. Multiply in pairs, it's c over a. Multiply all the roots together, minus d over a. So if we now go to a quartic, a power 4 polynomial, and I say that it's got roots alpha, beta, gamma and delta, well, I could factorize it like this. And I could now, very tediously, multiply out all of those brackets and compare coefficients. But actually, it's probably good as a mathematician to always try and spot patterns wherever you can. And we've already kind of spotted these patterns. So could we just write down what these are going to be? Obviously, you'd have to prove it if you actually wanted to use it. And you can. I'm not going to do it here. But can we just write it down? So if we add up all the roots for quadratic and cubic, we've got minus b over a. So we'll get the same again. Alpha plus beta plus gamma plus delta is going to equal minus b over a. And in fact, it's really all you need to remember is minus b over a, because the rest just kind of goes with it. So multiplying in pairs for the cubic, that was all of the pairs of roots multiplied together. There's a few more here. In fact, have a think. Can you think how many are going to be? 4 choose 2, 6. So that is alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. And that is going to be just c over a. Now in the triplets, all copies of 3. And that's going to be alpha, beta, gamma, delta. Nope, triplets. Alpha, beta, gamma. Plus alpha, beta, delta. Plus. So we've left, actually, let's do it in a better order here. So I've left out the last one. Oh yeah, no, that was the right. Alpha, beta, delta, leaving out gamma. Plus alpha leaves out beta, gamma, delta, plus leave out alpha, beta, gamma, delta. And that's going to be minus d over a. So the triplets, just like in the cubic here, is that. And all that's left is how we're going to incorporate e, and that's just going to be multiply them all together. And that gives us e over a. So, important things to note here. Minus, plus, it alternates sign. B over a, C over a, D over a, E over a. And with this, you could do the same for a quintic. It wouldn't be that good. You'd have wouldn't be that hard. One more root and you just add them all together. and that one will be minus b over a. Add up in pairs, c over a. Add up in triplets, minus d over a. Add up in 4 multiplied together, e over a. And then finally multiply them all together, all 5, and you would get f over a. So in summary, we have these following results, and they follow a really strict pattern. Add them up, minus b over a. Multiply in pairs, c over a. Multiply in triplets, minus d over a. Minus, plus, b, c, d, e, all over a. It may look like a lot to remember, but you don't. There's just a pattern. You just have to learn the pattern. You don't have to remember big long formulas, I promise you. I'm going to stop this video here. I haven't actually really asked to do anything. So after a quick break, we maybe rewatch it, have a quick look at that, and then we're going to do, the next video is going to be all about doing examples and setting you up for doing some questions. Okay,